All right. This is. I didn't have anything written down for this, but it was something I've been thinking about today, or just recently. And so I want to talk about it. Basically, we know that when when every material is heated up, it melts, right? And then after it melts, it vaporizes. And I guess the question to ask here is why? And then you would say, oh, well, because, higher energy, there's more movement, things fly around more. But then the question you ask is, okay, but why? You know, why would why would atoms want to fly around? Why does higher energy necessarily mean more movement? You know, why? What what is the real reason that that would be the case? You know, because it's one thing to say, well, um, you know, more energy, more movement, but that's just because that's what we observe. That's what we know. But like, why? And I don't know if there's a better explanation of a why out there, but maybe it has to do with entropy or energy dissipation. But I think that I'm going to kind of tie that in with what I'm saying. So, what I think is that at colder temperatures, lower energy, most things stay solid. I mean, everything is solid at some point, right? But a majority of material prefers to be solid because when you have low energy, right? When you're a material that took higher energy to create, you're trying to conserve that at a stable point, right? So compared to how much energy you are holding internally, the energy that's outside available to you is low. And so when there is a low amount of energy compared to how much you have, right, what you would want to do is you would want to maximize the possibility of collecting that low energy by minimizing the amount of area that energy could be. Like, I don't know, say you have like 5 rabbits in a pen, right? And you're trying to catch them. And so instead of trying to run after the rabbits in this like pen that's like 50 by 50 feet, you're going to build a net, right? Or like build a fence or something that you can slowly walk in. And as you walk in closer and closer, you're reducing the amount of area that these bunnies can run. And at some point, there's nowhere the bunnies can go, and you could just grab them, right? And so it doesn't have to be bunnies, but that's just an example, right? You don't have to eat the bunny either. It's just an example. If you're trying to catch the bunny for any reason. And so what I'm trying to say is I believe that the atoms are consuming this vacuum energy that's all around us, right? And so in order to maximize the vacuum energy interactions, they are minimizing the amount of space that there is. And so that is why we have higher density, larger atoms create higher density materials because they have higher energy in them, and so they have to minimize the amount of space in between the part of each other in order to maximize the energy returns. And that is why lower energy or less massive atoms or materials tend to be less dense because they don't need to tight as packly to get the energy that is needed to sustain themselves. And so what's basically happening is these materials are, say this rock, this little, well, it's not really a rock, but this little pebble, is basically condensed itself down really tight because the atoms that make it up require more energy, and so they have to reduce the amount of space so that when they are radiating their excess energy out, right, or trying to farm this excess energy, they are maximizing the amount of return. Because if there's, only so much area that these bunnies can run, you're much more likely to get one. And so basically, these materials, when they're at low energy states or solid, they bunch up really tight. But as you add more energy into the system, they no longer need to bundle up as tightly to get the energy that is required to sustain themselves, right? Because you have all this excess energy in there. Now they can send off more particles and interact with more virtual particles, and it's similar to, instead of like, say you're trying to catch a bunny, but instead of minimizing the amount of area to catch a bunny, you just add more bunnies, right? If the entire thing is filled with bunnies, you can't miss, right? They're everywhere. But if there's that is that's why, as more energy is added in the system, it allows them to kind of expand out. And when you have more energy and you can send out more energy, it makes more sense to make more room for bunnies. If bunnies keep plopping into your pen for some reason, right, you're gonna want to expand the pen size so that you can hold more bunnies in there, rather than so that, like, more bunnies to catch, right? Rather than keeping it crammed and then you've just got all these bunnies packed in one spot, and at some point there's no more room for bunnies. So you want to make the maximum amount of room possible. So as more bunnies are added into the system, you can expand the size of your pen and still guarantee you're going to catch one. And so that's basically what atoms are doing. And as they, at certain points, then they're like, they heat up more, and then they go from liquid, and then after they go to liquid, they go to gas, because they've just got tons of energy, and so they can they just are trying to constantly expand the amount of energy they can consume based off of how much energy they have. And so they're basically trying to keep it's sort of a balanced state in itself, because if you have higher energy, then you need to send out more energy, and you need to make more room in order to continue that high energy. And then over time, imagine whatever, if like you stop heating up the material, it's that excess energy starts to get spent, and as it gets spent, and realizes, oh, hold up, guys, bring it back in. We don't have as much energy anymore. So in order to keep that kind of balanced state and keep themselves sustained, they, slowly bring themselves back down to their solid state again. And for some materials, like water, it doesn't need to, it's a light enough atom that it can sustain itself at room temperature as a liquid, right? Or it gets enough energy in to sustain itself at a lower temperature, and so its solid state, we know, is ice, but Um, even when even when ice forms, honestly, I don't know if this is true for everything. I think it may not be, but I'm not even going to talk about that actually. Um, uh, Basically, I think that that's the dynamic process that's kind of going on there, and that's why these um, uh, particles do this. And it's maximizing the amount of energy being converted and dissipated, and so it's also maximizing. They're also maximizing energy entropy increase by doing this as well. So they're doing a great job at increasing entropy, which is in a sense everyone's job. So it's also doing that, but I think that it probably is a little bit of both there. I think the entropy increase is a side effect. It's not necessarily the goal of atoms to increase entropy. It's just what they do as a result of converting this energy from, dark energy into regular energy, and then eventually into dark energy into matter, and then into dark matter. And so, uh, yeah, I don't know if I had anything else to add on with this, but I think that uh, that makes a lot of sense. So I don't know if that's like a thing or that's like whatever, but that's just my thing that I was thinking about. Um, so yeah, peace out.